Zoom because it's easier to hear all the talks today.
Yeah, very exciting.
There was just an announcement that the meeting is already being broadcasted via YouTube, so we don't have to start now, but it's just for you to know that, you know. So just go home. There she is. Professora, a senhora fala primeiro, tá? Daí depois eu...
Não, fala você primeiro.
Eu primeiro? Tá bom.
Silene chegou.
Anfitrião aí agora.
So I think we can wait a few more minutes because we don't have like as an opening many statements to make, but perhaps we should start. We could start at 8:45 if everyone agrees. Professora Margarida.
Ah!
O Alex também está aí, ó.
Ei, Margaridinha. Bom vê-los. E também vai ter gente que vai entrar, que tem outras
YouTube,
coisas.
né?
Não, e que vai entrar ao longo, na sala ao longo né, das apresentações, não vai estar aqui o tempo todo, né?
Sim, sim, sim.
Se você me permite um palpite, Vitor, dos meus 2 dias de chicotinho, não deixa atrasar muito, porque depois a gente não consegue, isso vira uma bola de neve, porque cada sessão é 5 minutos, é 3 minutos, é 7 minutos, e daí... Então, eu te aconselharia a não começar muito tarde, não.
Tá bom. É que até o Siddharth também não chegou ainda, né?
E é ele o primeiro, deixa eu ver aqui.
É ele o primeiro.
Entendi. E vocês não vão
que
falar muito.
Daqui a pouco, a gente vai, no máximo 15 minutos a gente vai falar.
Ok.
Não,
só estou partilhando a minha experiência de chicotinho com vocês.
Eu tô com medo, mas vai dar tudo... A gente estava comentando exatamente isso, de como não deixar... Não vai ter... Senão a gente perde o almoço também, perde o coffee break, daí não fica legal.
This is a snowball movement.
Yes, exactly. Precisely.
Deixa eu só ver se eu acho o link do YouTube, que eu me perdi agora.
O Kim tá aí, tá não?
O Kim já conseguiu, já passou.
Tá. Já tá online.
Já tá online. O Fernando compartilhou aqui. Vou ver. Ainda não está aparecendo para mim online aqui.
Sempre demora um pouquinho, Vitor.
Demora um pouquinho, né? Então vou esperar aqui. O Fernando vai estar ajudando a gente hoje. O Fernando é meu aluno, com da Ana Shea. Eu estou perdido aqui, mas o Fernando vai auxiliar a gente na troca de mensagens com o YouTube para a gente...
Fernando, obrigada, viu?
Contemplar todo mundo. O Fernando foi acionado no final da noite.
Pois é.
Coitado do Fernando.
Muito obrigada.
Gentilmente aceitou. Cadê o Gabriel? O Gabriel também já está aí. Também. Eu vi o Gabriel entrando.
Eu estou por aqui.
Oi, Gabriel.
Oi, Gabriel, também obrigada.
Bom dia, gente. Todo mundo.
Oi, Sibaldo. O pessoal está tentando... Fernando, você pode mandar o link do Zoom para a Marie? Ou se puder compartilhar no LE, no grupo, por favor, o Fernando ou o Gabriel, fazendo favor. A gente compartilhou o YouTube inicialmente, depois achou mais tranquilo compartilhar o Zoom para ficar uma discussão mais próxima, mas lembrando que a gente não vai deixar o pessoal do YouTube sem
Participa.
isso. Oi, Gabriela.
Oi, bom dia.
Bom dia,
Esmeralda,
Vitor.
Oi, Gabi.
Alex, pessoal.
Tudo bem?
Tudo bem?
Bom te ver aqui.
Será? Cadê o Siddharth, hein? Vou precisar do chicotinho. Eu estou indo para o Rio Grande do Norte a semana que vem, já vou levar um chicote.
Helene, nós somos de você nessa. Achou ele?
Oi, Silene, bom dia.
Ei, apareceu!
Como é que vocês estão? How are you doing, everybody?
Hello, how are you?
How are you?
Então, Siddharth, como é que é o Rio Grande do Norte?
Uai, quente.
Você sabe que eu vou para lá semana que vem, né?
Ah, é?
Vou.
E eu vou para aí. É aniversário do Serginho.
Aniversário do Serginho, putz, cara, você acredita que eu não vi o Serginho até agora?
Sério?
Depois que o Serginho chorou no aeroporto o dia que vocês foram embora, cara, eu amo o Serginho de paixão. O Serginho ficou assim, morando no meu coração.
Mais interessante ele. Como é que vocês estão? Como é que está o Arthur?
Arthur tá bem, tem para a escola. É doido atrás do Ernesto, claro, né? Todo dia, mãe, eu posso ver o Ernesto? Eu posso ver o Ernesto? Fiquei morrendo de pena esse final de semana, cara. Eu tive de trabalhar igual uma louca. E ele queria trazer o Ernesto para cá. Eu falei, cara, não vai dar. Esse final de semana não dá. Quando eu voltar do Rio Grande do Norte, aí eu vou
Aí você
chamar a
confere.
Natália e os meninos.
Você fica de quando a quando?
Eu vou ficar de segunda a sexta. Vou
Poxa,
descansar um pouco.
fizemos, trocamos, sim.
Trocamos, exatamente.
Bom dia. Eu caí na internet. Bom dia, Siddharth. Tudo bem? Muito prazer te conhecer.
Prazer também.
Uma alegria você ter aceito o nosso convite, participar. A gente agradece muito.
Isso aí. Bem-vindos.
Obrigado, Esmeralda.
Vitinho, acho que a gente...
Vamos lá?
Vamos lá.
Vamos lá. Silene, eu acabei, a minha internet acabou dando um pico, ela está dando de manhã, e eu acabei saindo do papel de co-host. Só para, se puder, me tornar de novo, só para eu compartilhar, eventualmente.
Acho que quem é o co-host agora é o Kim.
É o Kim?
Quem é
É o anfitrião, o host.
Ele é o anfitrião, então ele é que tem de tornar você o host. Ele está aí, será?
Não, quem saiu?
Então vamos achar o Kim.
Bom, good morning, everybody. I will start with a very brief welcoming to everyone. So we are pleased to welcome you to the first workshop on evolutionary linguistics hosted by the annual meeting of the Working Group on Theory of Grammar, a branch of the Brazilian National Association of Graduate Programs and Research in Letters and Linguistics, AMPOL. The Working Group on Theory of Grammar, currently coordinated by Professor Silene Rodrigues, PUC-Rio, and Professor Maria Cristina Figueiredo Silva, from Federal University of Paraná, set up this year an independent commission dedicated to drawing attention to studies on language evolution in our national scenario, highlighting the need for linguists to participate more closely in discussions on the theme, which are being developed not only within linguistics, but especially, if not primarily, by other related fields. Professor Esmeralda Negrão from University of São Paulo and I were elected to act as coordinators for this commission. An additional goal of this commission is to familiarize our fellow linguists and graduate students with the methods and strategies currently being employed to develop research in this area, with the aim of debating the relevance of including as part of our research agenda a level of explanation concerning the evolution of our linguistic capacity. We, as coordinators, believe that linguistic theorizing should dialogue more intimately to what is currently being discovered about the evolution and development of our species. After all, the system we have been describing as composing our linguistic knowledge must be evolvable. Given the formative and introductory nature of this workshop, we commissioned to our renowned keynote speakers, who we enormously thank for their kind and immediate positive response to participate in this workshop, talks that could enlighten us on a particular subject matter encompassing language evolution, considering a pluralistic perspective, not only in the approaches to describe our linguistic knowledge, but also in the fields with which linguistics should be more closely interacting. The subject suggested comprise general questions that any linguist should consider when addressing a level of evolutionary adequacy in their personal research, as well as the strategies that linguists could adopt to develop a fruitful discussion with related fields. For example, psychology, anthropology, archaeology, ethology, evolutionary biology, paleoanthropology, among others. We also asked them specific questions that are at the forefront of the debates on language evolution. We mentioned just a few. Which are the most relevant developments in theoretical linguistics that allowed us to understand and reconstruct aspects of the evolutionary development of human language? How indirect evidence could elucidate facets of language evolution? What the multilingual capacity of human beings can tell us about the emergence of human language, language acquisition, and language change? And how the brain studies of other species and us can inform us about the evolutionary development of crucial brain areas involved in the processing of human language? We hope the topics that will be discussed today might kindle our interest in works on language evolution. As a result of today's interactions, we tentatively aim to mitigate the general view that language evolution concerns a branch of linguistics isolated from linguistic theorizing, or that it is a mystery rather than a research question, offering to you an invitation to tackle language evolution as a fundamental part of the linguistic theorizing in itself. Before initiating our activities, we would like to thank the initiative of Professor Silene Rodrigues and Professor Maria Cristina Figueiredo Silva of drawing attention to research on language evolution, inviting our Brazilian fellow linguists to think about such a topic as a relevant and approachable research question, whose results may have immense consequences for linguistic theorizing. We thank them for the opportunity of exploring this topic as a community. We also thank once more our keynote speakers for accepting to contribute with us, bringing in their expertise in so many areas, and for addressing crucial issues for elucidating the evolutionary history of our linguistic knowledge. So I wish you a very productive day and enjoyable day. And now I pass the word to Professor Esmeralda to welcome you too.
Good morning, good afternoon, everybody. I also want to welcome everybody to the workshop on evolutionary linguistics. And I want to thank our invited speakers that kindly accept to contribute with our workshop, the coordinators of the work group on theory of grammar of Paul, that opened room in their program for the discussion of this subject, which is very important in our view. I want to thank Victor for the partnership in this adventure, and I thank for all the participants in our audience today. I just want to reinforce some of the things that Victor mentioned, that linguistics has attained a body of important knowledge on the properties of this human capacity language, but we didn't open us up to include the subject in our agenda, and mostly we did not open ourselves to try to find strategies to develop a fruitful discussion with related fields on the topic, namely biology, history, psychology, anthropology, archaeology, ethology, among others. We hope that this workshop would be a beginning in this direction. Thank you very much again, and let's have a very productive meeting.
Thank you, Esmeralda, and thank you all that joined us so early. I would like to introduce our first guest speaker. I'll make a short introduction. As our first invited speaker, we have Professor Siddharth Riberu from Federal University of Rio Grande do Norte. We are extremely thankful for your acceptance to be with us this morning. Siddharth Riberu is Professor of Neurosciences and Vice Director of the Brain Institute of the Federal University of Rio Grande do Norte. He holds a BA in Biological Sciences from the University of Brasilia in 1993, a Master in Biophysics from the Federal University of Rio de Janeiro in 1994, a PhD in Animal Behavior from the Rockefeller University 2000, and a postdoctorate in Neurophysiology from the Duke University 2005. He has experience in neuroethology and molecular neurobiology, working mainly on the following topics: sleep, dream, and memory, neuronal plasticity, vocal communication, symbolic competence in non-human animals, computational psychiatry, neuroeducation, psychedelics, and drug policy. His talk today is entitled Mental Mapping Through Graph Theory. Professor Siddhartha, thank you once more, and the floor is yours.
Thank you very much, Vitor, Esmeralda, for the invitation. Thank you, Silene. We're good friends for years, and it's a pleasure to be among you all this morning and be able to share some of the results that we got in our research team. I think that my perspective, what I will bring today, is probably tremendously heretical and will ruffle feathers, and people will. And then I have other things that I need to attend to, so I will not stay when you start to say this is all very perhaps not proper, but we'll see about that. So let me see if I can share my screen review. Oh, I need some permits to share my screen, right?
Peter, you are the host, so you should make him the co-host.
So as I said, I'm no longer a co-host because
According to Kim, you are.
Who's the host?
According to Kim,
no, I'm not. As I said, I got disconnected, and when I got back to the room, this host title was removed from me.
So now we have a ghost host.
A ghost host.
You are the host, Silene. You are the host.
I'm not, unfortunately. Oh, maybe I am. Hold on. Let me see if I am. I am.
Yes.
I am the problem here.
Thanks, Christine.
I
That'll make it easier.
Really early. Last night, Siddharth. That's the problem.
Sorry, Celine.
So you are now the host, Peter. Peter,
Eu?
you are the host now,
okay.
making the co-host.
Thank you. Just did
Actually.
Okay, can you see my screen?
Yes, yes.
Okay, so I'll tell you about research that I developed in my lab in the past 15 years in collaboration with Mauro Copelli from the Federal University of Pernambuco. And in particular, it's the work of Natalia Mota, who was a master's student and a PhD student and a postdoc in both labs. And it really began when I arrived back from my postdoc in the US. And until then, I was just doing research in the brains of rats, of sleeping rats. And then when I got to Brazil, I realized there were so many disadvantages of being here, but there were also some advantages. And one advantage was that I could expand and research different things, and there would be less barriers to this. So I started to record dreams in the lab from humans, and then I started to investigate the dreams of psychotic patients. This is the work that Natalia began. And then from then on, we went to schools, we went to illiterates, we went to Native American groups, etc. So this is the result of this effort. This notion that you can use words to map minds, to use somehow words that people speak or words that people hear as a way to probe what is the organization of the mind of that person is something that we could trace back to Avicenna, who 1,000 years ago did a very pioneering study of investigating the reactions in terms of changes in the pulse rate, the emotional reactions of people as measured by a physiological parameter. How would those measures change as people change their feelings as they heard spoken words that could talk about something beautiful or horrible or involving love or hate and so on. So he figured that somehow the emotional reactions were measurable, and he could use words to probe that. 900 years later, Carl Jung, founder of analytical psychology, did a very interesting pioneering work of word association in a very quantitative manner. He would present words to people, they would give a response. So there was a stimulus word, there was a reaction time that was measured, then people gave a response. So it was a way to somehow probe the system and map connections, map relationships. It's a very heavy study, full of data, but he didn't have computers, and statistics the statistics field was still not so well developed. So in the end, he concluded only one major thing from this study, that people were clustered in two groups: those that had formal education and those that didn't have this opportunity. So the associations were much more varied and rich among people that had formal education. Around the same time, before Freud and Jung met, Freud and Bleuler and Kraepelin, the founders of psychiatry, they disagreed on many things, but they agreed on one major thing, that there was a striking similarity between dreams and psychosis. They believed that psychosis was an invasion of the waking life by dreams, which is a notion that has been receiving support in the past 10 years or maybe 15 years from neuroscience, but it was forgotten for a long time. And of course, we know that psychosis is something that is not specific to a certain disease. It's something that can show up in schizophrenia. It's something that can show up in bipolar disorder when people are manic. It can also show up when people have epilepsy with a focus in the hippocampus. It can also show up when people take 150 micrograms of LSD. So how does the psychiatrist knows that this person that is showing psychosis is actually coming from one one path or another path. This is a concrete problem in the clinical work, right? What are the symptoms that will accompany this condition? Well, thought disorganization. This is something that psychiatrists learn to recognize almost like an art. You know, they have to develop a sensibility for that. Flight of thoughts, people just change topics, move from one topic to the next. Alogia, logorrhea, and word salads. Down the road, if people continue to have psychotic events, they will converge to a situation in which nothing really makes sense and the discourse seems like random. So when I arrived in Brazil in 2005, I brought with me two books. One was The Interpretation of Dreams by Freud, and the other one was a book on graph theory. So graph theory is something that was developed, you know, hundreds of years ago by Euler, and it began with the consideration of this problem of the 7 bridges of Königsberg. And the idea was to build a path that would go through the city and cross all the bridges without having to return to pass twice through any building, through any bridge. And so to simplify the problem, he converted the different islands in little circles, in what he called nodes, and then connecting those nodes, you have edges that can be directed or not directed, right? So you can have a situation in which you have a network that just has edges with no direction, like a bridge. You can go either way, or you can have something that has a definite direction. You're not going back, and this is like text. In text, you go from the first word to the second, to the third, to the fourth, and so on. So when we began this work, Natalia was still in her undergrad, and she had access to patients undergoing psychosis, either with a schizophrenia diagnosis or with a bipolar disorder diagnosis. We began to investigate what was going on with their dream reports. And this was coming from the interest in the lab in psychoanalysis. And for comparison, we decided to see what would happen when they were talking about their waking life. In the beginning, we considered nodes to be syntactic elements. But then later on, we realized that the numbers we could crunch from the graphs wouldn't change much in average if we just took one node per word. And I know most of you are probably already despairing, but this is what happens when biologists and psychiatrists and physicists start to analyze text. So from the graph, you can extract many different things. You can extract the number of nodes and the number of repeated edges, RE. You can extract the average shortest path, ASP. You can extract the large strongly connected component, the LSC, and many other things, numbers that you can take from the graph that express its structure. And then you can use this as an input to a classifier, and you can calculate the area under the receiving operating characteristic curve, which is basically a way to estimate how many false positives and how many true positives and false negatives and true negatives you have, so that you in the end say, okay, I actually am above chance. If you have an area under the ROC curve of 0.5, it means that you know nothing, that you're basically classifying by chance. Our first study was a study in which we compared two groups of disorders with a control group. These were subjects that were already, undergoing schizophrenia for years. So people that were already, sometimes in their 30s, in their 40s, and that had, undergone treatment for many years. So this is it's not like a very clean comparison, because people have a lot of baggage here in this first study. But we noticed that when we colored the nodes differently, depending on whether you say this is related to the dream or related to waking, to waking things, not the dream, you can see that controls, they stay on task. They basically, you task them about a dream and they tell you about a dream. It's all blue. But in mania or in schizophrenia, people will have flight of thoughts. They will just drop, go away from the topic and then come back again. So we could measure that, and we could also see that there was a big difference in when you compared schizophrenic graphs from people with schizophrenia and graphs with people with mania. People with mania are going to have these very complex, very flourished graphs, and people with schizophrenia quite the opposite, you know, very, very laconic. We can use the graph measures to tell apart those groups, so you can start to classify those groups based on the structure of those graphs. We developed an automatic manner to do this, so it's this free software that we made available, you know, many years ago, called speech graphs. You can basically come with your text and it will give you the graphs, it will give you the numbers that you can then use to do statistics, classification, so on. And the things that we have been measuring are those that I mentioned before: the number of edges, the number of nodes, the connectedness thing, you know, that has to do with how many nodes are connected together in the same components. And the LSC is the part of the graph in which all the nodes are mutually accessible. So this is like the most strongly connected components of the graph. In the second study, 2 years later, after two years after the first study, we went back to the same problem, but with a larger sample, and then we made a very explicit comparison between the graphs obtained from waking, from vigilia, which is down here, and the graphs obtained from dream reports, which you can see up here. Okay, and what is very obvious is that the graphs from waking, the graphs that are obtained, like tell me what happened yesterday in your life, they are not that different among groups. The patients with schizophrenia and patients with bipolar disorder will tend to tell you stories of their waking lives, which are to a large extent chronological. You know, I woke up, I had breakfast, and I went there, and I worked, and I studied, and then I had lunch, and blah, 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 and then you go to sleep. You can see that there's some loops. There's some odd loops that you see in those discourses that you won't see in a healthy individual. But these loops are not, when you crunch the numbers, it's not significantly different. It's because there's a lot of variability also across subjects, right? And so if you just were based on waking report, you wouldn't be able to use those graphs to help the diagnosis. There's not enough difference there, okay? However, when you ask them about dreams, boom. You know, you can visually see, you can visually verify that they're quite different. And when you crunch the numbers are quite different. Now one problem is that people have, of course, their psychopathological condition, but they have other things going on that will determine whether they are more or less verbose, whether they will use more words or less words to tell their story. Right. So, and there are different ways in which you can control for that. One thing you can do, which we did later on, was to just limit the amount of time that they can speak, and then try to help get people to talk all that time. Another way you can go about this, and this is what we did in this study, was to use a moving window. Just calculate the graph for the first 30 words, and then, you know, jump 15 words and do it again, and then do it again, and do it again, and do it again, and then take an average of the measurements. When we did that, we realized that there were very clear differences between subjects with schizophrenia, with bipolar disorder, and the healthy controls. And these could be, you could also detect some of those in waking, but they were very, very clear when you compared the dream data set. And then we could tell very well the difference between subjects with schizophrenia and the control subjects using those measurements. Not so well for schizophrenia and bipolar disorder when you do the moving window. When you do the moving window, you see that the structure is not that different. It is different, but not that different. What you see here is a representation on the y-axis of the different graph attributes that we measured: loops of one node, loops of two nodes, loops of three nodes, you know, and so on. And here you have items in clinical scales, in the clinical scale called PANS and the clinical scale called BPRS, which are standard psychometric scales to assess psychosis and changes in thoughts. And what you see here in colors are the correlations that we got. In blue, all the correlations, all the significant correlations are indicated by a white ring. So everything that is circulated by a white ring is indicating a strong relationship between a graph measure and a clinical measure. And what you see is mostly have correlations with the negative part of the scale. So our graph measures are mostly capturing the so-called negative symptoms. What are negative and positive symptoms in psychosis? Positive symptoms are those deliria, hallucinations. People are just telling you stuff that they are the only ones that can experience. And it's very obvious because people are expressing that. What is not obvious is the negative symptom, is when people are, introspective, when they are going inwards. And then apparently our measurements are picking that part of the symptomatology, which is actually not as easy to get, because when people don't say anything or say very little, it's very hard to extract, to extract data from that. But graph measures with a little bit of data, you can actually grasp that. We decided, actually, in response to a reviewer, the reviewer said, well, maybe this is completely specific to Portuguese. So we just did a simple Google translation of all the texts, at face value. And we showed that we could still classify the subjects independent of the specific language. Of course, these are all European languages, many of them related. So I don't know what is the value of that, but needed to show it to you. Okay, so we were stuck with this question. Could it be that dreams are really that important? Which is something that Freud said. Freud said, if you want to know the mind of a person, if you want to map the mind of a person, get a dream report, right? Dreams are the royal roads to the unconscious. So we decided to go back at this question, get a new sample, but this time get subjects on their first psychotic episodes when they were in average 15 years old. Now, this is an important sample. Why? Because these people are going through their first episode, and if we could predict whether they're going to develop into a schizophrenia phenotype or into a bipolar disorder phenotype, then we could also, if we could predict the diagnosis early on, we could make sure that the course of action, that the therapy is correct. This is a big problem for adolescents that get their first psychotic episodes. They get a diagnosis of, say, schizophrenia, and then 6 months later, a year later, the psychiatrist will say, well, I changed my mind. It's something else. And then you had 6 months or a year of medication, which actually changes a lot your cognition during a very critical moment of your life. Every time there's a psychotic episode, there's a decrease in the cognitive abilities. So this is something to be prevented, and early diagnosis is essential for that. So we decided to do this. These subjects were followed for 6 months, and we did the analysis based on the first interview when they first got to the service and presenting symptoms. And then we decided to compare, because when you compare two things, you say, well, a dream report versus a waking report. One is better than the other. So what, right? Chances are something is going to be better than another one. But then we decided to compare dreams with more than that. So we showed people negative images with a negative affective content, positive images, right? So something that looks a baby, a cute baby, versus a beheaded person in a negative image, a neutral image, a car or a telephone, then a memory from yesterday, and then we asked for the oldest memory, because we said, well, maybe the dream is like a very old memory, something you're not totally sure, and let's see if an oldest memory will do. And this is also for practical reasons, because when you ask for dream reports, many times the patients don't have a dream to report, but they can always rescue an old memory. So we said, let's try that. What we found is that the differences that we had seen in the adult subjects, chronified subjects, were very obvious from the first interview. Okay, here you see a subject in the schizophrenia group. Here you see a subject in the bipolar group, in the control group, and you see that this largest strongly connected components, the part of the graph in which all the nodes are mutually connected, this increases in those groups. Okay, and it's very small in the schizophrenia group. So it's very small here in the schizophrenia group here. So we published this work in 2017, showing that in the first interview, 6 months in advance, you can tell whether this person is going to be diagnosed, because the schizophrenia diagnosis, it really takes 6 months to have like the golden standard, the SCID instrument to measure it, it's something you complete after 6 months. And we showed that what we could predict in the first interview, what would happen 6 months later by independent psychiatrists. In this study, we went further in analyzing the structure with using the notion of random graphs. So the question here became, we have this particular structure. This person told us this dream that has that structure. How far from random is that structure? So one way to discover that distance is to shuffle the graph 1,000 times. Just shuffle the words 1,000 times and compute 1,000 random graphs and compare the numbers that you get from the actual graph to those. Okay, what we found, this is an example of one subject in each group. Okay, so the actual values are in red and the random values are in blue. In the case of the subject with schizophrenia, you see that the actual value is well within the distribution of values that you get from the random graphs. So for this particular subject, if you look at the LSC of the graph of this subject, it's basically a random, something you could obtain by in a random graph. In the case of the bipolar example, you see that it's still within those values, but it's going to the right. It's getting away from that distribution. Okay, so it's less random. In the case of the healthy control, you see that it's really to the right of all the blue values. So it's something you shouldn't be able to obtain randomly. Okay, here this is looking at the whole group of subjects. 64% of the subjects in the schizophrenia group had values that fell within 2 standard deviations of the random, of the mean of the random values. Okay, so 64% of the subjects in the schizophrenia group were not distinguishable from random. This number was 30% for the blue, for the bipolar group, and it was only 5% for the control group. Okay, so now we're pointing in the direction of word salad. We're saying the people in the schizophrenia group are people that are starting to have a certain disorganization of their thoughts that allows for the discourse to be often indistinguishable from random. And down the road, this means the person will start speaking nonsense, complete nonsense. This is what we believe. Of course, we don't have these data, but this is what we believe. If you look into those discourses, it's still not nonsense. Okay, it's weird, but it's still not complete nonsense. It takes years. It takes many recurrences of the psychotic episodes to really get to this word salad point. And then what about this issue of how special are dreams? So this is the areas under the ROC curve. So basically, how well you classify schizophrenia subjects away from the other ones, comparing the dreams, the negative images, the positive images, the neutral images, the yesterday memory, and the oldest memory. And what you can see clearly is that the dream beats everything. The dream is really informative. Okay, the second best thing is the negative image report. It's very emotional. Then not as informative, the positive images. And then neutral images, yesterday memories and oldest memories, very close to 0.5, not very informative. So when you have a lot of emotion, informative. When the emotion is negative, even more informative. And when it's about a dream, super informative. At this point, we decided to get a little bit away from the psychotic subjects, and we decided to look into typical development. What would happen during typical development? Could we see, so we see that subjects that are 15 years old and that have a psychopathology like schizophrenia, they will have a discourse that instead of becoming more complex and with a larger LSC, they will start to shrink. They will go down in those values as something that is being lost. So could it be that the same thing that is being lost during psychosis in the adolescents are the things that are gained when children are learning to read and write? This was the question that motivated our study. This is something that we did in the school environment. This is Ernesto, my son, with Natalia, when he was in the school here in Rio Grande do Norte. We went to his school and we applied pretty much the same techniques, the same reports for short-term memory, for long-term memory, yesterday memory, oldest memory, dreams, and so on. Then they were exposed to reading and math tests in the schools, IQ tests, and theory of mind tests. Okay. Here, theory of mind tests, which are also very standard. I don't know if everybody is probably familiar with that. You know, basically asking stuff that a 3-year-old will fail and a 7-year-old needs to pass. And we were getting these children when they were just at this, you know, making this transition. What we found is not very surprising, is that the children with low academic performance, with low IQ, with low theory of mind, with low reading and math scores were those with very simple graphs. And those that had high performance IQ and TOM and so on had very complex graphs. So this is not that surprising. And this is just for you to compare with the schizophrenia and controls, for example. Okay, so it seems that these differences are arising early on. And does it have to do with education at all? And can it be just explained by IQ and theory of mind? Maybe these measurements are just reflecting IQ and TOM. So we calculated correlations between, you know, reading, IQ, theory of mind, and the connectedness, the LCC of those graphs, and we found that there was, you know, significant moderate correlation among those things, and also connecting reading to all that. Then we decided to adjust those measurements by IQ. So let's say the correlation between reading and speech connectedness adjusted by IQ. Does it survive? And it does. Okay, so it means that when you correct for IQ, you can still have a connection here between reading and connectedness. But the connection between reading and theory of mind disappears if you correct for IQ. Well, it doesn't disappear, but it's not significant. The same thing when we adjusted for theory of mind, right? If you adjust the correlation between reading and IQ for a theory of mind, it disappears. But the connection between reading and connectedness does not disappear. So basically, the graph measurements are offering us something that is in addition to what we learned from IQ and theory of mind. It's not this. It's not. It doesn't get explained away by IQ or TOM. Okay. So we're basically saying that during adolescence or early adulthood, people that have already a well-structured discourse will see this discourse be degraded by the psychopathological condition in a way that undo what was done early on in formal schooling. This was what we believed was possibly true. So we decided to investigate this in more detail. We expanded our sample, right? You can see here in typical subjects, a child and an adult. And what you see here in gray is a circle that goes around the largest strongly connected component, the LSC. And you can see how typical subjects will have an increase, an expansion in this LSC, but this expansion is not there for subjects with psychosis. Well, some expansion, but not much. What you see here are comparisons of values for nodes, for repeated edges, for largest strongly connected component, and for average shortest path, 4 different measurements pertaining to different aspects of graphs. For children below 12 years of age in light blue, for adults above 12 years of age, and for adults with psychosis. And what you can see is that the values that you obtain for adults with psychosis are quite similar to the values you obtain for children. This is not to say that the psychotic discourse is childish, but this is saying that it has similar structural features. We did then, we calculated adjusted correlations for age and education. What we found is that when we corrected the correlations obtained with age by education, they would disappear. But when we corrected the correlations with education by age, they would resist, they stand. Okay, so this, it seems like this maturation of the discourse as measured by graph measures is something that really depends on education. That education is the process that is driving this change in discourse structure. So for example, if you look at the number of nodes, which is a proxy for lexical diversity, the number of different words within a window of 30 words, this is exactly what we're graphing here. What you'll see is that for healthy subjects, you'll see a very crisp exponential saturation, which has a characteristic time within the first year of education. So children will get into school, you know, with a lot with very little diversity, and they will very quickly acquire a vocabulary that is diverse, using this measurement in particular, and this will sort of stay stable for the rest of their, you know, until they're adults, which is not just, I mean, of course, when you ask an adult about, you know, ask for a dream report, the words will be different from the words used by children, but the amount of different words will be similar. You don't have a relationship that is significant that you cannot adjust this exponential saturation in the if you compare with the psychotic group, okay? You don't have this. Actually, if anything, it seems to be decaying slowly. When you look at short range recurrence, the number of repeated edges, right? How many times you have this back and forth between words. This is something that is very high when children are very young, but in the first year of education, it drops dramatically. You know, as soon as they go into the social environment and, you know, there's like a social norm, they will just, you know, curb it down, boom, gone. Very quickly. And if anything, you see the opposite among the subjects with psychosis. It's something that it's not significant, but it's fitting the opposite curve. When you look at the other aspects that we investigated here, long range recurrence and graph size, we see that it's not something that happens in the first year, nor in the second, nor in the third. It's something that will happen way later. The characteristic time of these exponentials fall between 12, 13 years of education. So we're talking about something that will take a long time to mature. And I think this is just one more brick in the wall of saying people need to complete high school. It's if you want to have a mature discourse, there are things that will take many years to mature. And you can see that in the sample of psychotic patients, the red data, you see similar fits, but they do not achieve significance. This is to show you the characteristic times that were calculated for those attributes. So nodes and RE, very early characteristic times, and average shortest path, which is the graph size, and the LSC, the connectedness of the graph, much later, many, many years later. So this is really giving us a hint that education is making a difference. And so we decided to compare what will happen, if we put side by side, preschoolers that are not yet knowing how to read and write, literates, illiterates, and preschoolers. What you see here is that indeed illiterate adults are in between preschoolers and literates, because of course they're illiterate, but they have been exposed to the discourse of literate people throughout their lives. They meet people that know how to read and write all the time, and they talk to them all the time. So, it makes sense that they have something in between. I don't know how much time I still have. Let me see. Oh, I still have time. Okay. I have until 10, right? But we should have some conversations. So
yeah, no, but you have enough time. We should have at least 20 minutes of conversation, or 15 minutes. So let's see, 19 minutes. Yeah.
10 more, 20 minutes more.
Yeah. Let's say 17.
Okay.
Okay. Thank you.
Absolutely. So it was, I don't know, it was maybe 2014 or 15. We at some point we started to think that these results, maybe they could be useful to investigate an entirely different data set. Maybe we could use those graph measures that seemed to be relevant for diagnosing schizophrenia, for describing illiterate populations. We could use this to do some mind mapping way in the past, to do some mental archaeology. So is it possible that these things that show up in psychotic samples could also show up early on in the historic record? Could it be, because this is a notion, and I'm going to go talk more about this. This is a notion that has been going around, that maybe psychosis, which is now considered a disease, was something that was adaptive, that was positively selected, in different moments in history and prehistory. So could it be that the literature of antiquity is structurally similar to psychotic language? Could we find any similarities there? And would any change in graph attributes, would graph attributes change over time? And if they change over time, what is it that those changes tell us about history? Can we learn anything about history by looking into the changes in graph attributes throughout the written record? I have also to say that this is, this is also, we also went in that direction because it's fun and because it's very inexpensive. And as you know, Brazil has been undergoing 5 years of destruction of science and environment and society and decency. And this seemed like a way to continue research, have fun, and at a very low cost. Disclosure. So we decided to go back to texts that were originally carved like this, but of course they were investigated, they were deciphered, they were translated again, then we lost all the records, then we found them again, they were burned and so on. So of course we're talking about something that is very removed from the original source, and this is a caveat that I want to disclose up front. And the notion that one thing that I want us to bring to register as we look through the results, is the contribution of two thinkers. One is Karl Jaspers and the other one is Julian Jaynes. Karl Jaspers proposed in the 50s that there was a very special moment in human history between about 800 before Christ and 200 before Christ. Actually, this is B. This is not AC. This is... Oops. And he said, well, this is a moment when, when we came of age. This is the adolescence of the human minds. And things became very different after this border. Now, 800 before Christ is about the time when Homer, if Homer existed, when Homer was writing the Iliad and the Odyssey. So we're talking about the very early moment in the Greek society in which this, what we understand as Greeks, became to be written down. And of course we know that the Troy fell, the historical Troy was an event that happened 500 years before that. So we're talking about texts that have a lot of things that we don't know about them, but analyzing the thoughts and the different contributions, the different philosophical schools, Jaspers said that something very different had happened around that time. And this has been considered a non-testable hypothesis, a non-scientific hypothesis, something that cannot be put to test, okay, in the more Popperian sense of science. Popperian sense of science. Now, in the 70s, Julian Jaynes published a very influential book, The Origin of Consciousness in the Breakdown of the Bicameral Mind, in which he basically proposed that schizophrenia is a remnant of a past in which it was actually adaptive. And he's basically saying that in the Bronze Age, people were very often, hallucinating, listening to voices, listening to the commands of gods. And there's a whole, lots of ideas in this book, very interesting. When he was published, the New York Times called him the new Freud. But then over the years, it became forgotten. There's a cult of people that really like it. It's a very infectious book. If you read it, you tend to agree with it. It's very, very interesting. But it was also deemed as non-testable. He's basically proposing things that we cannot assess. Some years ago, some friends of mine physicists and people in computer science, all Argentinian, a bunch of rascals in the University of Buenos Aires and also IBM, decided to test the Jane's theory. And they said, well, it's basically saying that the mind that we have now is something very recent. It's something as recent as the beginning of the axial age, about 800 years before Christ. So if this is true, introspection, the concept of introspection, should not be something present in those early texts. It should be something very, very recent, because the whole theory of Jane's is about how introspective consciousness was born, around this time. So they decided to use semantic approaches. Everything I showed you today is non-semantic, right? It's all about structure. But then they decided to use semantic approaches. They used latent semantic analysis to calculate the amount of introspection in those texts. Of course, the word introspection is not even there in those texts. So, and this is actually an advantage. It's like a probe word that is a ghost probe that you can then use to measure average similarity. And when they did this, what they found is that the Old Testament has very little. The New Testament has more introspection. Confessions by St. Augustine has way more, okay? And you can see this here organized by a number of words in the Old and New Testament. This is also true for the Greco-Roman tradition. You see here the Iliad and the Odyssey with very little introspection, and introspection increasing exponentially as they go up. And then the same thing happens in the Roman texts. Okay, this is something that is very interesting. I was the editor of this paper when they published it, and I decided to go in this direction myself in my lab. We have a student that just finished the master's using similar techniques, and we were able to replicate these results and extend them. But I don't want to show this today here. I want to show some results that we obtained with graph theory, which is the topic of the talk today. So what we did was to expand their data sets tremendously. We got over 1,000 texts from the earliest texts in Sumeria in Egypt until blogs from the internet. We got texts we randomized the way we collected texts from public sources. We got oral texts from Amerindian populations. This was a very complex paper because we had to deal with many reviewers from many different fields, and they were always asking for something different. But in the end, we were able to publish it, and the results go like this. So we got our samples were comprised Syro-Mesopotamian literature, Egyptian literature, Judeo-Christian, Hinduist, Greco-Roman, Persian, medieval, modern, and contemporary. What we found was the following. Looking into those 4 graph attributes that I mentioned before, nodes, repeated edges, LSC, and average shortest path. And now comparing side by side the data from development from healthy subjects and psychotic subjects with literature. The pre-axial literature, the literature of the Bronze Age, is in white. And the literature from after the Bronze Age, from axial on, okay, from 800 before Christ on, is in black. And what you can see here is the black and the blue are always quite similar. So the structure of post-axial literature is quite similar to the structure of oral discourse of healthy subjects nowadays, okay? And the discourse of children in light blue, of psychotic subjects in red, and pre-axial literature, Bronze Age literature, very similar attributes. So if structure-wise, you could say that the discourse of children and the discourse of psychotic subjects is similar to the discourse in the Bronze Age, structurally. Now, this is looking at all the data, okay? Above, you see every dot is one book, one text. And of course, you can say, well, but these texts were not published as different books back then, right? For example, the Book of the Dead in Egypt, you have 1, 2, 3, 4 if you go to the public source, but they sometimes they're together in the same papyrus, sometimes they're separate. It's more complicated than that. And this is why we did also a nested analysis, an analysis by tradition, which you can see below. But the story is not very different. What you see here is that lexical diversity has been increasing in a sustained manner. Over time, there's more lexical diversity. So, and this is within a window of 30 words. So we're talking about lexical diversity within a certain window, okay? And then moving the window through the whole text, doing the moving average approach through the whole text. The short range recurrences, which you see going down in the discourse of children when they go to school, this took millennia to go down, a long time to go down. Okay, long range recurrence, which you see going up, very similar in terms of the curve during development and maturing around 12 years of education. You see that it also took a long time to mature, and the graph size seems to be just increasing. It will, I'll show you later that it will saturate way in the future. And the nested data tell you sort of the same story. Okay, the exact numbers of the fits are not the same, but they're quite similar. Now, one thing that was very striking for me, this came to me as a discovery. A few times in life, you really look at something that you were not expecting. And I was not expecting to see such a stark border, a sharp border between 900 and 800 before Christ, which is what Jaspers predicted, okay? I was not expecting that. It's very clear. And this, again, this is not data from a single lab. This is the data this is our data. This is data from the humankind. You can add more books, but this is pretty much everything that was available. And this border is there. So this is saying that the largest strongly connective component was very variable in the Bronze Age. And then it started to decrease. And then when the Bronze Age came to an end, when there was a civilizational collapse with actually an increase in illiteracy and an increase in wars and famine and cities disappearing and so on, which is this border here, which I mark as a collapse. It's the very low level for the LSC. And then when the axial age begins, boom, it goes up to another level. There's a discontinuity and it stays up there since then, okay? In fact, it's very interesting that the structure of the, one thing that I must mention, here you have the random level. We also calculated random graphs here. So you see that the LSC was decaying through the Bronze Age, going towards random. So maybe this is saying the society is becoming more and more psychotic, who knows? But then there was this big collapse and then it goes up and stays up again for a long period of time, for all the time since then, away from random. If we compare this distance to random, and we look at the structure on the x-axis of the short range recurrence and in the y-axis, the long range recurrence, what you see is that the sheer structure of the text can tell you about the passage of time. We color the text by the dating of each text. In blue, you have the old texts. In red, you have the recent texts. And you can see that only looking at two components of the structure, you can already reconstitute the arrow of time. You can see that all the new texts are to the right and up, and all the old texts are to the left and down. And it's remarkable that the temporal distance, the number of years between one of the earliest texts, for example, instructions of Shurupag, very old text from Sumeria, and say the Republic of Plato, this distance is about 2,000 years. And it's the same distance between the Republic of Plato and the Candide from Voltaire. So it's 2,000 years. But these 2,000 years, structurally, they were nothing. The structure of the Republic is very, very similar to the structure of Candide. So it had already matured. This is the point here, is that during the axial age, this structure matured. This is like how it got to be structured from then on. And the most of the change happened for LSC between the earliest texts and the axial age. This is a comparison on the top. Yes.
Just a short note to say that you have 5 more minutes.
5 more minutes.
Yeah.
This is a comparison of the characteristic times for ontogenetic dynamics and for the historical development. And you see that there are similarities and differences. So for example, repeated edges, in both cases, something that matures early on. And in the case of average shortest path, in both cases, something that matures later okay? But for nodes and for LSC, the relationships are reversed, okay? Nodes mature early on during schooling, but they actually matured late in our historical development. In fact, the characteristic time is in the future. This maturation is yet to happen. It's still happening, and the average shortest path, the maturation is around 100,000 years from now. So at some point we could not get the paper passing through some this is a paper that is very heretical, and there was a lot of opposition. The first preprint was available on the internet in 2016, and the paper was only published in 2020. And at some point, one of the reviewers said, I don't buy this. I think that the structure of these Bronze Age texts is like that just because they were more close to the oral traditions. So this is just something that you will see if you get, say, Amerindian narratives. You should have something like that. And another reviewer said, no, I think this is because those old texts were very poetic, and this is the structure of poetry, and it has nothing to do, and so on. So we decided to compare all those groups and compare illiterate adults and preschoolers. And what we found is summarized here. On the left, you have the data. On the right, you have the theory. So the data are showing that the post-axial texts, if you just look for the two components, RE and LSC, the short range and the long range recurrence, post-axial texts are very, very well separated from everything else. Then at a distance, literate adults. Then there's a big cluster that gets illiterate adults, psychotic adults, literate children, and Bronze Age texts all clustered together in terms of those two structural features. Preschoolers are somewhere else, okay? And the Amerindian narratives are very separate, very different. They have their own structure. They're not the same as Bronze Age texts. They have their own structure, quite distinct from poetry, say from Shakespeare on. So those arguments, they were not really arguments, right? But because if they happen to have similar structures, so what? But the fact is that they don't. They have separate structures, considering those measurements. We do not have a sample of very young discourses from very young Native Americans. This is something that actually Selene tried to help us with this. We went to a Guarani settlement near Rio de Janeiro, looking for these dream reports from Amerindian children, but we couldn't get that. But we can presume that the structure of the discourse in children before any education goes on, or little education goes on, is similar across, white and indigenous peoples. They're probably born, very likely born the same way. So we, in the theory side of the plot, let's assume that this is the start point for the structure, and this means that there are two different trajectories that you can take depending on whether you are in a literate environment or in a non-literate environment. Why do I say this? Because for among the different Amerindian groups, for example, the Kalapalo that we studied with special detail because of our collaborator, Antonio Guerrero, who's a specialist in the Kalapalo. It takes 12 years, about 12 years of education for children to become adults that can speak to the group. When they need to learn how to speak, there are several rules about how to speak. And these rules have to do with a lot of postures and gestures, and you need to look down, put your hand on the head and so on. But the way you use the words has to be very repetitive. This is the way to do it properly. So in the literate environments, we tend to increase the LSC and decrease the number of repeated edges, because in fact, you don't want to be repetitive. You want to use the power of the book, the power of the written text to free your working memory and be able to develop your reasoning and have a very have the long range recurrence increase a lot, okay? And you see this in literature. But in the oral traditions, there is no written support. So the value is put in the repetitions. The repetitions will allow you to anchor what you need to remember. right? And if you go into those texts, you see that they go and say 1, 2, 3 things. They go back to the first, they go back to the third, and they reiterate many times, but many times, many more than would be done randomly. So what you see is really different paths depending on whether you have a support, a physical support, or you don't. And if you have only your memory, then those resources seems to be something very important and very valued, because when people don't go through this education and don't learn how to speak like this, they're not listened to. People don't pay attention to them. This is very clear among the Kalapalo, but among other groups as well. So as conclusions, and I'm finishing, we see that the Bronze Age literature is somewhat similar, structurally similar to the discourse that you can get from psychotic patients and children. There is an abrupt transition in the structure of texts near the beginning of the Axial Age, 800 BC. The history of writing seems to recapitulate, at least partially, the effects that education has on the speech of a healthy adult. So over 12 years of education, children undergo structural changes as measured by graph measures that took 5,000 years to arise. So it's really a condensed exposure to this transformation of the discourse. And we see that the structural randomness of long-range recurrences seems to be an immature feature of discourse, both individually and historically. So you begin quite close to random, and as you develop, you go away from random. I want to thank all the different agencies that used to fund the research, some that still do. I want to thank the many opportunities for getting good data from the internet for free, like the Project Gutenberg and the Digital Egypt for Universities, the Electronic Text Corpus of Sumerian Literature. And also want to thank the hospitals and schools where we worked to get data from the different samples that I presented. Thank you.
Thank you for such a fascinating talk. I truly thank you. And now it would be great if I could have a round of applause, but a virtual applauses. Now I move on to questions. So if anyone has questions, please. I will have 2 hands here. I for some reason I'm not being able to see them, but just Shigeru has his hand. Please, Shigeru.
Yes, hi, good morning. Can you hear me okay?
Yes, good morning, Shigeru.
Okay.
Nice to meet you.
Yeah, hello, that was fascinating, fascinating work. Thank you. I just wanted to ask you a question about something that you mentioned, that psychosis may have been an adaptive behavior. And I'm wondering what would be the evolutionary advantage to this condition?
Thank you for the question. This has been hypothesized in the 60s, 70s. Julian Jaynes was not alone there. And it's the notion that if you have a lot of inner life, if you have a lot of beliefs that allow you to have courage to do crazy things, sometimes you succeed. So for example, how did men colonize Polynesia? How many people traveled and found no island? So you gotta be, sort of like simplifying the argument, but you gotta be really crazy to do something like Thor Heyerdahl to show with the Kon-Tiki. So the notion here is that we were governed by the people that had the vision, the people that were manic, that were saying, let's go there, let's do this. I have a vision, I can see something that is not there. Moses, right? Moses says, let's get out of here, let's go into the desert and find Canaan. So was he a healthy subject? Or was he a bipolar manic subject? Now this notion, it has been put forth in a more or less flaky manner by many people, but Julian Jaynes actually did an investigation of what's actually said in many of those old texts. And what he reported in his book is that most often, the discourses are separate. So it's often in the structure of, I'm here, king such and such, in front of you, amazing God Marduk, and I'm here to hear your words. And then another discourse begins, which is a discourse full of commands. And he put forth the notion that people at that time, especially those that are at the top of the pyramid, the pharaoh, was basically hallucinating voices and was greatly valued for that because he had inspiration to do things and he saw things that nobody else could see. And this system probably originated very early on in the Paleolithic and then became very strong, and fantasy dominated human life for millennia. And evidence of this is all the ritual burials starting from Chukochen in China 300,000 years ago, and then culminating in the pyramids in Egypt. And at some point, this entire system collapsed. It could not provide answers for the changes that were happening. This happened between 1300 before Christ and say 1000 before Christ. And this is a moment in which there's a long period of silence, of hiatus of the silence of gods. So for centuries, the written record says, "Oh gods, why don't you talk to us anymore?" And after that, then a new mentality arose, and this was at the beginning of the Axial Age. And this is a new mind that is not listening to voices all the time, but actually talks to itself all the time. So it recognizes these voices as their own. I don't know if this makes any sense, but it comes from there.
Yeah. Thank you. I know there are a couple of people who also have their hands up. I just want to note very quickly that there may be something to this with regard to cave art, which is much earlier. Talking about 40,000 years ago.
Yes.
Cave artists were very deep in the caves. They stayed in deep in the caves for a long time. They're burning fire, so the bad air, and they were making a lot of noise, a lot of sounds. This is something that's come out recently. The cave art is actually acoustically based.
Right.
Something I wrote about with Vitor. And you could imagine that kind of environment would lead you to hallucinations. And there is an idea that cave art, in fact, was a ritual that celebrated other worlds. So I just wanted to note that, and I'll stop there and let the others ask questions. Thank you.
Great point. Thank you.
Thank you, Shigeru. So now we move to Sileni and then to Professor Bruno Franqueto for the three questions that we have.
Great talk, Siddharth. Thanks a lot. It was really inspiring. Thanks a lot. I have a question for you about writing system. So your talk indicates that language became more complex as we developed writing, right? The writing system appeared. So do you think that before the writing system, language were less complex? I mean, look, if you look at your data, if you look at the waking reports that you have, you and Natalia collected, what you see is that you have much less subordinated clauses. So it's a sequence of matrix clauses, right? One after the other. It's probably just like, I would say, I had access to those tests and I read them, to the reports. And what I see is there's just like coordination all over the place. But when you look at the dreams, then you see a lot of subordination. And if you look at what you were saying now, you were saying like, well, you get more complexity when you have a school system in place, when you have writing and reading. So do you think that this is part of the story for us to tell about the evolution of language?
I do. I think that yes, but I think it's also, there's a big problem there, which is a translation, right? And this is a problem that we faced when we were trying to get this paper published, is that, first of all, there are many ways of translating, and then how much is added in translation is hard to measure, and most likely it's something that is being filled throughout ages, so that in the end you sort of normalize everything. We did one control, which was to apply the same graph measures to transliterated data that was not translated, just words, and the differences are more extreme. So for example, there's even less lexical diversity.
Right. So that's a very interesting stuff, but maybe we can do this research now by looking at native people that do not have a writing system and comparing them with the others and see what we're going to get. What do you think?
I like it.
Bruno doesn't like it, so let's see what Bruno has to tell us. By the way, Bruna is an expert in native languages.
I know.
Okay.
No, I'm sorry. I'm full of doubts. I'm full of doubts and of questions. I cannot express all these of my doubts and questions now. I would like very much. You can maybe think about another next meeting in order to deepen a lot of questions. I loved the Siddhartha talk. Obviously, I'm fascinated since I don't know when. Evolution, the evolution of language. And sorry, but I want to switch to Portuguese because I'm tired and emocionada. O talk de Siddhartha me deixou muito emocionada, muito excitada, o que é muito bom. Mas eu acho que tem uma série de problemas que se apresentam, sobretudo, quando nós vamos começar a pensar sobre línguas, culturas, sociedades ameríndias, né? Sobre as quais temos pouquíssimos dados, pesquisas confiáveis, né? nesse terreno. Então, eu acho que devagar, né, com as generalizações, com dizer que chegou-se a resultados, eu acho que falta ainda muito. Primeira coisa, a Silene tocou a questão de writing systems, né? Writing, então, vamos começar a relativizar o que é writing. Estamos falando de alphabetical writing, né? Um tipo específico de, aspas, representação escrita dos sons da fala, né? Que é um tipo de writing system. Tem outros, né? E não estou só me referindo a ideogramas, né? Outros tipos de escritas. Mas estou me referindo ao fato de que os grafismos, sistemas gráficos, né, de grafismos de sociedades indígenas, são um tipo de escrita. E nessa direção que vários antropólogos, inclusive eu, no meu lado antropóloga, temos escrito sobre isso, né? Relativizar. O Peter Gal, para começar, a Luísa Elvira Belaunde, Elsie Lagru, Carlos Severi. Eu publiquei recentemente um artigo no num journal que eu não me lembro, sobre Cognition and Language. Mas, então, mostrando a complexidade dos grafismos e como os grafismos devem ser considerados, deveriam ser considerados uma forma de aspas e aspas e aspas, writing, né, de escrita. Então, tem isso. A questão da educação, você falou que é educação escolar, né? Que tipo de educação é a chamada de nossa educação escolar, né? Isso não quer dizer que é uma educação em contexto de não escolaridade, né, de oralidade primária, etc. As observações de Antônio Guerreiro, meu grande amigo e colega, com relação aos Calapalo, é verdadeira para uma pequena porção do processo de educação linguística entre uma sociedade ameríndia como os Calapalo, que não é bem uma ethnicity, singularizar uma ethnicity, é um grupo envolvido numa rede regional. Não temos quase nenhuma pesquisa de aquisição da linguagem em sociedades ameríndias, né? Muito pouco, pouquíssimo. A minha observação, eu trabalho há mais de 40 anos com um grupo próximo dos Calapalo, quer dizer que tem que olhar para a fala cotidiana, do dia a dia, em contexto doméstico, onde as crianças são completamente ativas linguisticamente, onde se dá a chamada, que podemos chamar de educação linguística primária. Então, não dá para generalizar de etiquetas de comportamento verbal em situações de interação mais ou menos formal para uma generalização sobre sobre a fala, a educação, digamos assim, eu não gosto da palavra educação, linguística ou verbal em sociedades ameríndias. Então, eu só digo, vamos devagar com as louças, né? Vamos devagar, porque falta muito conhecimento e muita pesquisa para chegar a resultados e generalizações. O que foi dito pelo Siddharth de maneira muito sintética, obviamente, sobre os Kalapalo, não pode ser generalizado. Né? Dizer, isso aqui é válido para outras sociedades ameríndias. Não é. Nem entre os Kalapalo, inclusive. Mas o Antônio está falando de um determinado aspecto. Né? Bom, essa é só, na verdade... Eu não tenho pergunta, era só um comentário que estava, assim, umas reações, não são nem comentários, são reações que estavam meio entaladas e que eu achei que precisava colocar sobre dreaming. Bom, convido a ver o livro da Laura Graham sobre dreaming, e o discurso sobre dreaming entre os chavantes, um artigo antigo do Woodcrack sobre os discursos, a falas, né? O report, dreaming report, among the Kawahi, né? Um povo de língua tupi-guarani, sendo que interessante que nas línguas tupi-guarani tem um reported evidential, né? Um evidencial de reported speech específico para reported dreams. Plenamente específico para isso. Isso deve existir em outras, das muitas línguas da família Tupi-Guarani, e deve existir em outras também. Mas é isso, desculpem a reação. Mas a reação só existe quando a provocação é boa, né? Então, obrigada, Siddhartha. Mas eu acho que...
Eu fico honradíssimo de você estar aqui e de você fazer todas essas provocações, e eu sou muito atento a que a gente tem que pisar muito suavemente. A demora desse artigo ser publicado, inclusive, é uma expressão disso. A gente mexeu em muitos vesperos e a gente teve que fazer muita coisa ao longo do processo para poder manter o diálogo, né? E a nossa colaboração com o Guerreiro foi nessa direção. Até por causa disso, a gente no artigo separou os dados de Kalapalo dos outros dados, e a gente viu que tem alguma diferença, e o Guerreiro tem falado isso, dito, olha, a gente precisa aprofundar isso, fazer mais pesquisa, olhar mais, enfim, não enxergar isso como um porto de chegada, mas como um ponto de partida.
E ter pesquisas detalhadas sobre a língua, conhecer a língua, né? E não se basear em traduções, nunca. Nunca se basear em traduções.
Essa é uma questão que está a gente discutiu isso demais, né? Se a gente tivesse feito todo o artigo baseado em dados transliterados, a gente teria dados muito mais... as diferenças seriam muito maiores, mas o corpo seria muito menor, porque tem muito menos coisa. Então, enfim, mas eu recebo muito bem tudo que você falou e te agradeço. E que
obrigada a vocês. Obrigada.
Well, I have to wrap up just to...
Can I just make one comment, just a short...
One comment? Okay.
Short one, I promise. Siddhartha, about lexical increasing, right? You showed that over time you had more words, right? So I think it might be related to amount of consonants in languages. There is this research showing that when you have large populations, they increase their amount of consonants, and consonants are used for lexical building. So maybe that's something that has to be considered here as well. I'll talk a little bit about it this afternoon.
Quite interesting. We need to talk.
Well, I have to be the annoying person here, just to say that we have to wrap up to move on. But again, I want to thank you, Professor Siddhartha, for kindly accepting our invitation and for bringing us such a fascinating topic. So I truly thank you, and I thank the audience for bringing in such enlightening and provoking questions.
Okay. Thank you all. And praise your initiative. I need to teach a class, so I cannot stay, and I'm sorry about this. I'm curious about what everybody will say, but I will catch up with Silene later.
Okay. Thank you. So now we move on to the talk by Professor Shigeru Miyagawa. I'll make a short introduction. Professor Shigeru Miyagawa is Professor of Linguistics and Senior Associate Dean for Open Learning at MIT. As Professor of Linguistics, he has published several books, including 3 recent ones from the MIT Press over 60 articles. The latest book will come out in a few months from MIT Press, Syntax in Treetops. He has recently developed a theory of language evolution that hypothesizes that human language arose from the integration of 2 pre-existing systems in nature, one seen in birdsong, the other in primate alarm calls. His ideas are developed in jointly authored articles in Frontiers in Psychology from 2013 to 2019. The integration hypothesis received mention in the journal Science and in its news website, and was featured in other respected international scientific news websites, including the BBC and National Geographic, among others. His talk today is entitled On Darwin's Song Proto-Language. I also want to make a short comment. Professor Miyagawa has a direct role in the first steps of studies on evolutionary linguistics in Brazil. His lectures over the last 5 years invited scholars from many disciplines in Brazil to think about language and evolution. And I think that this workshop directly reflects his contributions over the last 5 years. So I immensely thank Professor Shigeru Miyagawa for accepting to be here with us and to provide us with a discussion on language evolution. So please, the floor is yours.
Thank you so much, Vitor. That was a very kind introduction, and so nice to be with you this morning. It's a beautiful day in Boston. In fact, I had to close the shades because my room was getting so bright. This is the cave where I have been living for the last 18 months, and pretty much like the caveman of early Pleistocene. I haven't been drawing cave art yet, but if this continues, I may very well start doing that. Yes, I'm at MIT. I've been at MIT. Actually, you can tell by the rocking chair behind me. You get that after 25 years of service at MIT. Like, thank you. Relax. So I've been there a little bit longer than 25 years, but it's been just wonderful being able to visit with many of you in Brazil. It's been a long time since I've been able to do that. I hope to be able to do that, as soon as this pandemic settles down, and that we can begin to interact, like Homo sapiens learn to do, instead of this Zoom world that we've been put into. And so I thank you for the invitation, and let me share the screen. Okay. Okay, so this is a talk on a paper that I'm now writing. It's based quite a bit on work that I've done with other colleagues, including Vitor. I wanted to push a little bit on some aspects of things I have been thinking about with regard to certain parts of human language and how that may have developed. And so I'll go into that. Okay. So Charles Darwin made an observation that birdsong is the nearest analogy to language. His idea was a speculation, but an interesting one. Said that that there are a lot of similarities between birdsong and human language, and we'll get into it in just a second. And there's some amazing similarities, quite amazing similarities. And his idea was that we inherited from birds this ability to communicate through music, and that's how human language began, as song proto-language or musical proto-language. So we're sort of, singing to each other for a long time. That maybe sort of an interesting thing to do, at the next faculty meeting, for example. So what I want to do is to use this idea of human language as having originally started as musical or song in order to address a paradox that I see in human language and evolution. Okay, it's a paradox that people have talked about, not in terms of paradox, but in terms of people taking sides on how human language developed. Okay. So on the one hand, language is immensely complex, so complex, that it's hard to imagine that it didn't take a long time over evolutionary time, millions of years to develop. Okay, I mean, if you sit down and try to learn a human language today, it's very difficult. I mean, I tried to learn, for example, Portuguese, but I couldn't do it. It didn't help that every other student in class was a Spanish speaker, so it was not very fair. But there we are. Incredibly complex. Okay, and so something like this must have taken a long time. It's just common sense, and a lot of people referred to as gradualists. Many people subscribe to this idea that language took a long time to develop. But on the other hand, modern human behavior seems to have emerged around 100,000 years ago. The modern human behavior, things like music, sophisticated art, religion, and we put language into that, although language doesn't fossilize, so we can't really tell. And although there are few artifacts, few things, few behaviors that predate 100,000 years, something seemed to have happened around 100,000 years ago. Something clicked, and all of a sudden we have this explosion of modern human behavior. And it would be reasonable to think that human language emerged around that time. We have no evidence of human language prior to that time. Okay. So let me just quickly okay. For the gradualist view, there is sort of neuroscientific evidence in support of the idea that human language developed over a long period of time. Two areas of the brain that are critical to human language are the Broca's area and the Wernicke's area. Okay. Broca's area in the frontal lobe and Wernicke's area in the posterior part of the brain. Both are in the left hemisphere for most people. Okay. Broca's area is for speech production, among many other functions. Wernicke's area is for speech perception, among many functions. So you can see that these are critical to language. And there's evidence from study of endocasts, that is skulls, of earlier hominids, that Homo habilis and Homo erectus may have had these two areas in their brain. This is by looking at the inside of the skulls, and somehow the imprints can tell you the structure of at least the outside of the brain, and Broca's and Wernicke's are fairly new parts of the brain in terms of primate evolutionary history. So apparently it is possible to tell if these regions existed. And Homo habilis and Homo erectus, if they had these regions, you're talking about over 2 million years ago, long before human language appeared. Okay, they obviously were not using these areas for language because as far as we can tell, they didn't have language, but their brain was language ready, 2 million years, 2.5 million years before we started to develop language. So it would not be far-fetched to think that language developed gradually, taking advantage of the existence of these two critical regions of the brain. There's also evidence the homologs of Broca's and Wernicke's areas exist in some great apes. And now you're looking at 6, 7, 8 million years ago. Again, these great apes don't use Broca's and Wernicke's for language. They use it for other functions, but the homologs are there. And so the idea is that, the brain regions that are needed for language have been around for millions of years, long before our ancestors began to develop what we called language. And so it's not far-fetched to think that language developed gradually, again, recruiting these regions that exist in the brain, have existed in the brain. So that's sort of neuroscientific support for the gradualist view that language developed gradually over possibly a million-year period. Okay? Many linguists subscribe to this idea, very prominent people, Jack Endorf, Terelman, and many others. Okay? On the other side, in support of what's now called emergent view. Emergent view is the view that language actually arose about 100,000 years ago, and there was nothing like it before 100,000 years. There's some evidence that people have pointed to, not direct evidence, since again, we can't go back and look at language from 100,000 years ago. But one thing that people like Ian Tattersall, the very eminent paleoanthropologist, that if you look at the development of tools over the Pleistocene, we have the first tool, Lomekwian, discovered in Northern Africa. Looks like that, a big piece with one side napped, okay, from 3.3 million years ago. And then the next tool is the old one. Again, it was discovered in Ethiopia, smaller, with one side napped. Okay. And then some 700,000 years later, you have the early Acheulean. And then a million years after that, you have the late Acheulean. It's a beautiful piece of work. Late Acheulean, like early Acheulean, is bifacial. It has symmetry. Yeah? And also, for the first time that we know, late Acheulean shows not just utilitarian usage, but also artistry. So there's a fossil in the middle of this late Acheulean tool. It shows that the carver of this tool cared about what other people thought about this tool. Okay, so this was used to communicate, maybe even curry some favors. So the pattern that we see with early tools, Lomekwian, older one, early Acheulean, and late Acheulean, is that in between, there's as much as 1 million years between innovations. Okay? So Lomekwian tool discovered 3.3, discovered and dated to 3.3 million years. That did not spread. Okay? It was discovered in the Lomekwi region of Northern Africa. And as far as we can tell, it did not spread. It just sort of petered out. Okay? But the Oldon tool, which was originally developed by Australopithecus, like the Lomekwian, and then picked up by Homo habilis and Homo erectus, that got spread all over Africa, into Middle East, into China, into today's Russia, and into Europe. took 1 million years for our ancestors, hominids, to spread this all over this big terrain. But during that time, the older one tool did not change too much, okay, for 1 million years. Early Acheulean, which was bifacial, also was around for 1 million years. And until late Acheulean, which is a much more refinement, it did not change. And then the late Acheulean. Okay? So huge, huge time gap. But then you have Mousterian 300,000 years ago. This is Neanderthal. Okay. Marked a point in time when something happened so that about 100,000 years ago, okay, tool making became really, really fast, speeded up, not million years, but in thousands of years. Okay, so as Ian Tattersall suggests, something clicked in our brain so that we began to, our ancestors began to process information in a fundamentally different way. And this is the time when modern human behavior began to emerge in sort of massive form. Music, cave art, sophisticated weaponry, and so forth. Not only that, but before you had one or at most two stone tools in the same region, okay? The old one and Acheulean in Africa. Okay? But beginning around this 100,000 years ago, you had this incredible explosion, diversity of innovation and styles. Okay? So this again reflects, according to people like Tattersall, some fundamental transformation in our cognitive system, so that not only did we speed up our thinking process, and so innovations came in really rapid progression, but also that innovations developed this huge diversity. Okay? And diversity is something that you see in nature. Nature likes diversity. You look at language. Okay, presumably language started maybe 100,000 years ago, but today we have over 6,000 languages. Okay? So nature likes diversity, but that diversity began apparently around 100,000 years ago. Something else that people who subscribe to the emergent view point to is this very famous piece, the ochre piece, discovered in the Blombos cave in South Africa. There are like 8,000 pieces discovered in the Blombos cave. And as you can see, it has engravings and etchings, which are quite regular. And paleoanthropologists who subscribe to the emergent view suggest that this regular pattern that you see here is a somehow a proxy, or it's a reflection of symbolically mediated behavior. Okay? And that's what modern human behavior is, symbolically mediated behavior. And of course, human language is the epitome of symbolically mediated behavior. And so people, again, like Ian Tattersall, have suggested that the existence of this piece, which has been dated back to 73,000 years ago, it's in the ballpark for the emergent view, that this is a reflection of a mind that is producing symbolic representations. It got externalized as regular engravings in ochres, but it would be reasonable to believe that at the same time, people were producing language. Okay, so you have the gradualist view, which is based on common sense that human language so complex must have taken a long time to develop. And there's even some brain evidence that regions of the brain needed for language have been around for millions of years. Okay? But on the other hand, we don't really see the kind of behavior that we would expect of Homo sapiens who had language until about 100,000 years ago, with this explosion of modern human behavior. So what I suggested in some earlier articles was that maybe both are right. Both gradualist and emergent views are right. And that if you look at components of today's language, the components have been developing for a long time, as the gradualists have suggested. But sometime around 100,000 years ago, as our brain was getting transformed in ways that we can see from tool making and others, something happened such that these components that have been developing separately in our brain somehow integrated uniquely in humans to give rise to human language. Okay? I call it the integration hypothesis. Okay? So what are the components? The two components that I talked about are the expressive system and the lexical system, the E system and the L system. Okay? E system is formation of patterns, and it's most clearly evident in birdsong. Okay? Birdsong is a system that creates patterns, okay? Patterns that don't have propositional meaning. Okay? Birdsong, the birds sing in order to convey intention to mate, for example. Okay? But it's not propositional. The L system are systems composed of isolated utterances. The easiest example are the alarm calls of, let's say, vervet monkeys that have calls for snake, leopard, and eagle. And these alarm calls do convey meaning with scare quotes, in the sense that a call, let's say for eagle, is made when there is a presence of eagle in the vicinity. So there is some connection to the real world in which the vervet monkey lives. Okay? The important thing with the L system is that they are isolated utterances, okay? Discrete utterances. Okay? So the expressive, which creates patterns, doesn't convey meaning, but conveys intention. And L system, which are, for the most part, isolated utterances, and they do convey meaning. And something that I noted in an article is that these are the two systems that you find in nature, two systems that you find in nature for communication. Okay? I believe that all forms of communication that we know of, right, fall into one of these, the E system, birdsong. There are primates that also have singing, some other systems which create patterns, okay, but not meaning. And then the L system, you find with alarm calls, lots of animals have isolated utterances for pointing out alarms, for other things. So E and L, I believe, are the two systems that you find in nature. In human language, E and L, you find E in for syntax, grammar. Okay, syntax creates patterns. The L system are the words. We just heard about a wonderful lecture about words. You know, an adult human being, we know about 60,000 words, okay? But these are discrete units. And the membership of that lexical set changes over time as we have different experiences and we learn new words, but we also forget words. But roughly, we operate on about 60,000 words. With the E system has only like 5 to 10 nodes, depending on the theory, okay? And they're very stable, and they're there to create patterns. So, and what I suggest is that that these two are separate components in human language, and they have been, developing for millions of years as E system, separate from L system, and that somehow they integrated in Homo sapiens about 100,000 years ago to give rise to human language. Okay. So, and I'll be talking about that. But I'd like to go back to Darwin's idea of birdsong and human language, because there's some striking similarities. Yeah. One similarity is that Darwin himself observed that the early stage of acquisition similar for birdsong and language. For birdsong, subsong, and for language, babbling, infant babbling. Okay, that's quite a insightful observation by Darwin. But it turns out that there's even more similarity, kind of surprising similarity in terms of acquisition. Okay? In both birdsong and language, we find two distinct styles of learning. Again, I've written about this in an article. Okay, it's been pointed out by Lou Gardner and Nuttenbaum that young birds, and they were looking at zebra finch, young birds adopt one of two styles of acquisition, which they call serial repetition and motif. Okay. Serial repetition is a style of acquisition where a baby zebra finch will take a small piece, what they call syllable, of the father's song, only males sing, father's song, and repeat that small unit over and over again. And because the unit that is being sung and repeated is small, each unit is clearly articulated. That's the serial repetition. The motif style is adopted by some other baby zebra finches. The motif style is where a zebra finch baby will copy a large chunk of father's song and will try to repeat it. And because the subsong that they are repeating is a larger chunk than serial repetition, each note is not so clearly articulated. Okay, I'll show you some spectrograms in just a second. But it turns out that human babies have exactly the same bifurcation of acquisition, what O'Grady calls analytic versus gestalt. Okay, for babies that adopt the analytic style, they take basically a word of their, let's say, mother's language and repeat that one word unit. And because the expression that's being repeated is small, the articulation is very clear. Gestalt style is where a baby will try to copy a larger chunk of the parent's speech. And just like with zebra finch, because it's a larger chunk, the articulation is not as clear. Okay? So we all acquired our language either as analytic or gestalt, or for zebra finch, serial repetition or motif, two very different styles. But for zebra finch, by the time of sexual maturity, about 76 days old, they all sing the song perfectly, and we learn language perfectly, regardless of whichever style. Okay? In these spectrograms, you can see serial repetition versus motif of zebra finch from Lou Gardner and Nuttenbaum. The three spectrograms at the top show serial style, and you can see that each unit is very small and very clearly articulated. The lower three spectrograms show motif style, where each utterance is a bigger chunk, and as a result, it's not so clearly articulated. Okay? So it's a very surprising similarity between human and bird song in terms of acquisition. Okay? So this gives further support to Darwin's idea that human language and bird song have some important connection in evolutionary time, evolution time. Something else between birdsong and human language that's been pointed out. This is Fenning et al., a very important, extremely interesting science article that came out in 2014. They studied the brain structure of songbirds, zebra finch, and humans, and discovered that zebra finch, songbird that sings, and humans have neurobiological structures relevant to song and language are very similar, with gene expressions creating very similar structures. Okay? You can see it in the red line. And what they also discovered was that birds that don't sing, for example, chicken, and primates that don't have language, macaque, here, C and D, don't have those structures. Okay? So here, there's a very striking neuroscientific evidence for Darwin's song proto-language, that bird song and human language have similar brain structures in relevant ways. Okay? So, but in order for bird song to have some connection to human language, some things must have happened. Okay? So what are these? Many, many things. I'll mention two. One is lineage. Okay? What does that mean? Well, birds and primates parted ways in evolution 300 million years ago. That's a long time. Okay? And so if there is any validity to Darwin's song proto-language originating in bird song, then the E system that we see in songbirds needed to have been inherited into the primate line or the mammal line of evolution, so that it's not just birds that have E system, but that we have E system all the way through the mammal and primate line. And in fact, there's evidence for that. Gibbons, small monkeys that live in Thailand, they sing, and they also have alarm calls. Their song is just an amazing song. They even sing duets. Male and female gibbons sing duets in the jungle because they live in the canopy, and at a distance, their songs are really loud and piercing. I work with Esther Clark, who is a gibbon specialist. And nowadays, Esther has gone to Thailand to do field work, but now I think a lot of the field work is done with gibbons in captivity in zoos. Okay, and so gibbons have both E system, singing, and L system, and alarm calls. The E system, which we believe has been inherited throughout the mammal and primate lineage, may express itself in ways other than singing. Okay? For example, facial grooming action of rats has been mapped as a grammar that is a finite state, simple finite state grammar. Berridge et al., 1987, there are others. What this suggests is that the E system, as it's inherited throughout the mammal and the primate lineage, may get expressed not just in terms of singing, but in other behavior, as this facial grooming action of rats. Okay? It's just a piece of software in our brain. So you could imagine that it's used for many things, but singing is the most evident one that connects us all the way back to bird song. Okay. What else does the E system need to have in order for it to become part of human language? So bird song and also other singing by primates is, as I said, it's patterns that are created, they're sung to convey intention, but they don't have propositional meaning. Okay? A nightingale, a beautiful bird, sings up to 200 different songs, but a nightingale does not pick song number 156 to convey a particular meaning. Okay? They sing to convey intentions, most commonly intention to the desire to mate or for territoriality. Right? And so in order for the E system that we see from bird song all the way through the primate system, it needs to become somehow propositional. It needs to take on meaning. Okay? A hint from Tecumseh Fitch, who's a very eminent evolutionary biologist, He says in a 2005 chapter, assuming Darwin's song proto-language to be the starting point, he says, he calls that musical proto-language, which may be more accurate for what Darwin had in mind. So assuming Darwin's say musical proto-language to be the starting point, a second stage must have taken place, which added a fully propositional and intentional semantics. Yeah? Meaning, right? That gets attached to the patterns being produced by the E system. So what, and I completely agree with Fitch, but what do we need for the E system to have in order to take on this fully propositional property? Well, basic requirement is that you need hierarchical structure. So in a simple sentence like this, the book you read is mine. You can see the kind of hierarchy that is mapped onto the words, so that it's this hierarchy that maps words to particular meaning. Okay? It's not just linear order of words, but the words are organized into constituents. Okay? And so minimally you need for the E system to be able to be associated with hierarchy. Okay? Birdsong is not hierarchical. Okay? Something as complex as Bengalese finch song, which has been studied by Okanoya, Bengalese finch, which is it's zebra finch that has been domesticated in Japan. Actually, Antonio may talk about this later today. So there are 7 notes, and Bengalese finch developed this ability to loop back from different points in the song, okay? So that you get number of different versions of the song, and it sounds quite complex, but each iteration of the loop is a linear and not hierarchical system combination. Okay, so birdsong is not hierarchical. As far as we know, only human language has this kind of hierarchy, so that the linear signal, in this case words, is not just linear, but that there is this abstract hierarchy associated with it that allows us to attach the E system to a hierarchical structure, which in turn will allow us to attach all of this to a fully propositional semantics, as Fitch suggests. So how do we mark hierarchy? Okay. Well, we mark hierarchy by prosody, relative prominence based on pitch, fundamental frequency, or by pauses. Okay, those are the 2 major features of prosody. Okay. A simple example pause that gives you that tells you what the structure is of a sequence of words. It's taken from Buring. So the sentence, when Roger left the house, became irrelevant. Depending on where you put the pause, you have completely different meaning. So in A, when Roger left, pause, the house became irrelevant. Okay. That gives you one kind of constituent structure. The other is when the Roger left the house, pause, became irrelevant. It has a completely different meaning, completely different propositional meaning because of the different sort of hierarchical structure that's associated with it. That's for pauses. We use pauses all the time to indicate hierarchical structure constituency. Within a noun phrase, you have, again, taking, so Selkirk points out that the last syllable of the word in a constituent has a relative prominence. So if you have fancy shirt and slacks, you see that shirt has more prominence than fancy, and in turn slacks has more prominence than shirt. And so you have this structure, fancy shirt, that creates one constituent because shirt has more prominence than fancy, and slacks has more prominence than shirt. And so you have this hierarchical structure, and it gives you the right meaning. But tie, shirt, and slacks has just one difference in prominence, and that's slacks. And so you have this kind of flat structure, tie, shirt, and slacks. Slacks is at the end. Okay. So this kind of prominence will give you different structures. Okay. So I'm just going to skip the. Yeah. So prosody is what signals hierarchy. And so, if Darwin's idea of language initially was singing, it was musical, how does this relate to prosody? Well, there's quite a bit of work in neuroscientific work that shows that music and speech prosody share in common the core elements of melody, intonation, and rhythm. Okay. For example, both music and speech recruit overlapping neural regions, including in superior, anterior, and posterior temporal areas, temporal parietal areas, and inferior frontal areas. Yeah. Infants show overlapping neural activity to infant-directed speech and to instrumental music. Patients with congenital deficits in music perception often also show deficits in pitch perception in language. Amusia subjects, people who cannot deal with music, either show reduction in both music and prosody discrimination, or both are intact. So if you lose one, you lose the other. If you don't lose one, then the other is also intact. So how does prosody, which we now know is related to music, mark hierarchy in the brain? Well, music is mainly processed in the right hemisphere of the brain. Prosody was also believed to be in the right hemisphere. Okay. But more recently, there's evidence to show that hierarchy is associated with the Broca's area, specifically Brodmann's area 44, which for most people is in the left hemisphere. Okay? So if prosody is going to be associated with hierarchy, somehow the right and the left hemisphere must work together. Okay? And there's in fact evidence for that. Okay? The yellow in the right hemisphere indicates activation just in the right hemisphere of what's called prosodic speech without any segmental information. So just sort of musical language without any words in it, and that only lights up the right hemisphere. But normal speech, which has prosody and words, will activate, as you can see by the green, both the right hemisphere and the left hemisphere. Yeah. The two hemispheres are neuroanatomically connected via the corpus callosum, and patients with lesions in the posterior portion of the corpus callosum, partly resulting in a disconnection of the left and right hemispheres, did not exhibit syntax prosody connection. Okay. These are experiments having to do with ERP and anterior negativity that presented prosody that did not match the structure of the sentence. Okay. And that will trigger anterior negativity in ERP. In the healthy brain people, indeed, you get the anterior negative response, but with patients with this lesion in the corpus callosum, that anterior negativity did not show up. Okay, showing that both hemispheres have to work together. Okay? So the E system exists today in birdsong. It also is utilized by other animals like gibbons. So the E system has been inherited through the mammal and primate lineage right into us, we believe. The E system is closely connected to music, which is associated mostly with the right hemisphere, but somehow the E system became associated with Broca's area in Homo sapiens, specifically Brodmann's area 44 in the left hemisphere. This allowed the E system mark hierarchy. Okay. So this is the enhanced E system. when we first suggested the integration hypothesis, I only had in mind this E-system, sort of like what we see in Birdsong and Gibbons. But now I understand that this E-system must have been enhanced. It's very specifically with the capability to represent hierarchy, which is the first step in becoming part of human language. Okay. Some questions that we wish we had the answers to, but we don't. You know, how did the original E-system get connected to Brodmann's area 44, Broca's area? How did BA44 develop the function to generate hierarchy? Okay, did the ability to generate hierarchy existed for a long time? Okay, or not? Okay, these are things that we need to find out. Although we are a long way from answering these and other questions, there are some intriguing hints. Okay, and I'll end with this. Humans can learn sequences based on hierarchy, the A and BM, and those without hierarchy, the AB, flat AB sequence. Cotton-top tamarin monkeys can only learn non-hierarchical sequences. A very famous article in Science by Fitch and Hauser. So cotton-top tamarins cannot deal with hierarchy, and that's what we expect. The hierarchical sequence activates Brodmann's area 44, the Broca's area, as well as the frontal operculum, while the flat AB sequence only activates the frontal operculum. A lot of important work coming out of Max Planck. The frontal operculum is a phylogenetically older part of the brain that than the Broca's area. So you have BA44, that's the newer part of the brain, and the frontal operculum. So tamarins have a well-developed frontal operculum, and this is what allows them to process the AB flat non-hierarchical structure. They don't have use for they are not able to tap the Broca's area that creates hierarchy. Okay? Now, humans, tamarins, and prosody. Okay. Human newborns can distinguish sentences from languages with different rhythm patterns, while perceiving no difference for languages with the same patterns. This is the experimental technique of sucking. If a baby hears something new, they suck quicker. And so if they're exposed to, in the case of Mahler, first Turkish, and then to French, which has a different prosodic pattern, then their sucking begins to quicken. But if they're exposed to two languages with similar patterns, then there is no quickening of sucking. This ability to distinguish different pattern languages disappears when they're played backwards. Not surprising. When exposed to pairs of languages that are different in rhythm, Dutch, Japanese, as Rasmus did, human newborns and tamarin monkeys perceived the difference. When played backwards, no distinction was perceived. In a follow-up study by Tinkoff, they used many more languages with newborns and tamarins. They found the same result. And so tamarins apparently have the ability to distinguish prosodic differences between Dutch and Japanese. Okay? They just don't have Broca's area, right? So this idea of enhanced E-system, I think responds to some criticism by people like Maggie Tallerman, who's a very eminent evolutionary linguist. Tallerman pointed out that, in critiquing our original idea of integration, that E-system, for example, doesn't look anything like human language E-system, and she's right. And so this idea today, the E-system had to have been enhanced minimally by being able to represent hierarchy. And the hierarchy is marked by prosody, I think is a response to Maggie Tallerman's critique. Fujita and Fujita made a similar remark. Okay, if you think about what we know about tamarins, tamarin monkeys, if tamarin monkeys had Broca's area like ours, they have lots of what's needed to develop language like ours. They have the frontal operculum, they have the ability to distinguish Dutch from Japanese. And so, maybe they're listening to us and trying to figure out how to get the Broca's area so that they can also participate in language communication like us. Okay, thank you so much.
Thank you, Shigeru. Thank you so much for such a fascinating talk. I have some questions, but I'll open up for the audience first. So if there's someone. There. So I'll make a short question. So thank you so much. I was wondering whether we get binarity from the system. So we have prosody that would be marking constituents, but in a sense, to get to hierarchy, binarity could be at play before prosody being marked. I don't know whether your system that you developed with the stair, the two system would have an impact on that, or if I don't know if.
Yeah, so one of my favorite topics. Language has this binarity property, A and B, but not A, B, and C. People like Chomsky suggested that this has to do with economy. Okay? Combining A and B gives you a unique node at the top, whereas if you combine A, B, and C, then you don't know exactly which one is going to project. I talked about this, interestingly enough, at a physics conference. They wanted people from other disciplines to talk about their achievements. And I talked about how language has this binarity, and they said, no, that's wrong. If that's true, then the whole universe should have this binarity property, and it doesn't. Physical world has its binary, trinary, and n-nary. Okay, so it can be economy, and that sounded like a pretty good argument to me. And so, where did this property come from? Well, if you look at Fitch and Hauser's research on tamarin monkeys and human language, notice that tamarin monkeys are activated frontal operculum. And Federici et al. Pointed out that the frontal operculum, which is the older part of the brain, which we also use, is there to create combinations of two things, but not more than two. Of course, there's one, like isolated utterances of vervet monkeys, but as I pointed out in an article I wrote with Esther Clark, there are old world monkeys that can apparently combine two things, but never more than two. And so in the article, we suggested that the system underlying communication in nature is either one, like vervet monkeys, two, as in old world monkeys, or infinite, human language. But the idea of binarity. As I was saying,
I joined in with 2 accounts.
Do you know how to get rid of the Zoom bomb?
Good. Working, it seems.
Oh, as I was saying before, I was so rudely interrupted. That was babbling. So it's possible that this frontal operculum that can combine two things, and that's a fact that we see in all world monkeys, that may be the basis for binarity in ways that I don't quite understand. But we know that human language taps not just Broca's area, but frontal operculum. People like Riberu say that the basic syntactic structure right at the base is created by frontal operculum, which is binary. But it's a speculation at this point, but it's a big topic. But I think physicists convinced me it's not economy.
Thank you, Shigeru. Now I'll move on to Sileni. Sileni has her hand raised.
Well, I think that with respect to this, to the binary property of language, we also have to consider memory, right? It might be relevant to this discussion. The universe does not have memories as we do, so probably it's part of the answer. But I want to ask you about the L system and the E system. So you draw a clear distinction there, and I think it's, we have lots of evidence that there is this division there. But do you think that is it possible for us to have the two systems? I mean, I ask that because I'm working with interjections and idiophones. And I think that maybe interjections and idiophones are actually evidence that we do have this, let's say, more primitive system that you are calling the L system.
Yes, I completely agree with you. Interjections usually cannot be combined.
Yeah.
Like verbate monkey systems, you cannot, combine whatever the examples of interjections you have and create new interjections. They are isolated utterances, and they don't have meaning. They don't have lexical meaning. They're there to convey some kind of emotion or some intention, and that's very similar, but it's very primitive. So yes, I completely agree that that's an area that we should study in terms of this primitive system that exists in human language.
Yeah, I'm doing this research with a colleague of mine from philosophy of language, Ludovic Soutif, and we did an experiment. We actually modeled our interjection sequences using data from monkeys. So we studied monkey calls, and then we did the interjections sequences like a person watching a soccer game, and producing a lot of interjections. And the results we got from participants, it was done in Brazilian Portuguese, is very similar to what we see in monkey calls, in the vocalization system. They are very emphatic systems, and the first position seems to matter. It's very interesting stuff. And I wonder if language as it is right now, it may have developed from interjections.
That's one theory, right? The lexical gradualists will say that language developed from isolated utterances that kept getting combined until somehow syntax popped up. Okay? Others say that instead of introductions, they're gestures pointing to things. Even Darwin said that. Darwin said that we started with song, but song doesn't have any lexical items. Maybe we started to gesture as we are singing. So you could imagine introductions getting embedded in a sequence of musical notes as a way to transform it towards language. Okay? Lots of sort of fun ideas. The problem is that we can't really come up with empirical evidence for it. So that's why I keep looking at our brain to see if there's anything that can tell us about our earlier period. But interesting idea.
Thank you.
Here we have one question coming from YouTube by João Paulo Bento. He asks,
I'll be chilling in the darkness. Yeah. Whoa.
People, I
There
think
is a way to
yeah,
keep
Yeah.
Zoom bombs out.
I think we have to change it. I hope I hope no one like really shared it widely because oh boy, but I'll take care of it. So we have one question by João Paulo Bento. He asks, has a similar research with tamarin monkeys has been made with domestic animals like dogs or cats? With millennia of human contact, they should recognize very well the language of their owners, no?
I didn't catch. Can you say a little bit more slowly, please?
Yes. Has a similar research with tamarin monkeys been developed with domestic animals like dogs or cats? In millennia of human contact, they should recognize very well the language of their owners.
It's possible. It's possible. Of course, dogs are sort of older animals than tamarin monkeys, and so it's. I mean, people focus on tamarin monkeys because they are domesticated, and there are ways in which you can do experiments with them, and you would expect them to be a little bit closer to what we have in terms of brain
in the
resources.
darkness. At my darkest. Oh yeah.
During the break, if you know how to keep Zoom bombs out, that might be a good idea, because this will be happening throughout the day otherwise.
Yeah, I'm trying to do that. I'm sorry.
No, that's okay. Yeah, if anyone in the audience knows how to keep Zoom bombs out, you could email Vitor.
Yes.
Vamos chamar o break, Vitor, e daí você vê.
Yes. So, well, thank you, Shigeru, so much. I really apologize. I truly apologize for such inconveniences, and I was not expecting that to happen at all.
You can't keep me out. You're just stupid.
Peter, can you make me
Dog.
lock this room?
Okay, and we go to a break, and then we come back at 11:30 Brazil time, 10:30 EST. Okay, and 1:30 CET. Okay. Again, thank you, Shigeru, and my sincere apologies for such inconveniences.
No problem.
Okay, I'm gonna get out of the room. I'm gonna lock the room, and then I'll come back again, okay?
But shouldn't we talk to the person at PUC to see how we can manage to do this?
I manage by, I'm gonna put a waiting room in the room, so that everybody that gets in the room has to be accepted by us. But
Okay.
to do so, I have to get out, and then we all get in again using the same link.
Okay.
Yes.
I see.
Very good. That's how you avoid the Zoom bomb. I now remember. Very good. So we all get out first, and then come back in, and Serena will let us back in.
Okay.
Okay.
Usar os
So
links.
make me the host again, please.
Yes.
E usar os links de ontem ou da sessão principal, que foi tudo bem.
You can't do anything to stop me. I'll still chill in the darkness.
It's gonna be the same link.
Yeah.
So please, everybody, we have to get out of the room and then come back in the same link. Is that
Right? The same, very same link.
okay? So see you pretty soon, and hopefully